Hey there, and welcome. Ever stop and think about what everything around us is actually made of? I mean, really? Well, today we're going to zoom way in, past what our eyes can even see, into the secret world of stuff. And our whole journey kicks off with a really simple question.
I mean, really, think about it for a second. You can pick up a rock, right? It just sits there in your hand. But water, it just flows right through your fingers. And air? Well, good luck trying to grab a handful of air. So what's the deal here? They all seem completely different, but believe it or not, they're all connected in a really cool way.
So the answer to this whole mystery, it's not something you can just see. Nope, it's actually hiding in a world that's so small it's totally invisible to us. We're talking about a world of tiny particles that are always moving, always dancing, and they're the things that build, well, everything.
All right, so let's get our imaginary super microscopes ready. It's time to zoom way in. We're about to meet the real stars of the show today, the fundamental building blocks of, well, everything.
Okay, first things first, we need to get the lingo right. The official word for all this stuff we're talking about, in science, it's called matter. And the rule is super simple. If it has mass, meaning it's made of something, and it takes up space, it's matter. Doesn't matter if it's a huge planet or a tiny little grain of sand, it's all matter.
So what's all this matter made of then? Get ready because here they are, molecules. Think of them like the universe's own Legos. They're the super tiny building blocks that make up every single thing you can think of. So you're probably thinking, okay, they're tiny, but how tiny? Well, get a load of this number. That is just mind-boggling, right? That's roughly how many molecules of water you'd find in just 1 liter. It's a number so big, our brains can't even really process it. And that just goes to show you how unbelievably small and unbelievably numerous these little guys are.
Now, to unlock the entire mystery of solids, liquids, and gases, you only need to know 3 simple rules about these molecules. Think of it as their secret code. Rule number 1, they are always moving, always. Rule number 2, there's always a little bit of empty space between them. And rule number 3, they kind of stick together because of this invisible force. Got it? Moving, space, and stickiness. That's the key to everything. All right, let's dive a little deeper into rule number 2. The space between them. This actually has a fancy name, intermolecular space. The easiest way to think about it is like personal space, you know? A personal bubble. And as we'll see, some molecules have tiny little bubbles, while others have huge ones.
And what about that stickiness from Rule 3? Well, that also has a name, intermolecular force. It's basically an invisible glue or a tiny magnetic pull that draws molecules toward each other. Now here's the most important part of this whole explainer. It's the constant tug-of-war between their movement, their spacing, and their stickiness that decides whether something is a solid, a liquid, or a gas. It's all a balancing act. Okay, team, we've met our molecules. We know their 3 golden rules. We now have all the clues we need to finally solve the big mystery. Why can you hold a rock, pour water, and not grab air? Let's do this.
First up, let's talk about solids. You know, like that rock from our question. Or maybe a block of ice, a piece of metal. So what are the molecules doing inside a solid?
Okay, so inside a solid, the molecules are packed in there super tight. Like imagine people in a crowded elevator. There's almost no intermolecular space. That sticky intermolecular force is at its absolute strongest, locking them all together. Now remember rule number 1, they're always moving. Well, they are, but they're so packed in that all they can do is just kind of vibrate in one spot. And that right there, that's the whole reason solids are solid. Because all those molecules are locked into that rigid, vibrating pattern. A solid has its own fixed shape and its own fixed volume. It doesn't change. And that's why you can pick up a rock and it stays a rock in your hand.
All right, that's solids down. Next up, liquids. Think about pouring yourself a glass of water. What's the molecular party like in there?
So in a liquid, things are a little looser. The molecules have more breathing room. That intermolecular space is bigger. And that sticky force, it's a bit weaker. This is the game changer, because it means the molecules aren't locked in place anymore. They can slip and slide right past each other. They can flow.
And what's the result of all that sliding around? Well, it means a liquid doesn't have its own shape, right? It just takes the shape of whatever you pour it into, a glass, a bowl, a puddle. But, and this is important, since those molecules are still pretty close and sticky, a liquid does have a definite volume. A liter of water is a liter of water, no matter the shape of its container.
And that brings us to our final state of matter, gases. We're talking about the air we're breathing right now, or the steam that comes off a boiling pot of water.
Oh man, gas molecules are on a whole different level. These guys are the wild ones. The space between them is massive, and that sticky force is so weak it's barely even there. They're just buzzing with energy, zipping and bouncing around like crazy in every possible direction.
So, because these molecules are just flying free, a gas has no definite shape and no definite volume. It'll just expand and expand until it fills up every single millimeter of whatever space it's in. And that is why you can't grab a handful of air. The molecules are just too far apart and moving too fast to be contained.
And there you go. Mystery solved. It all comes down to how much the molecules are moving, how much space they have, and how sticky they are. So let's just pull it all together and look at the big picture for a second. This chart right here is basically the perfect summary. Just look at the pattern. As you go from solid to liquid to gas, what happens? The space between molecules goes from least to most. That sticky force goes from strongest down to weakest. And those two changes right there perfectly explain why the shape and volume change the way they do. It all goes back to our three simple rules.
So, okay, we've learned a lot about molecules, but what's the big takeaway here? Like, why is this so cool to know?
I think it's this. The world that looks so solid and still to us isn't still at all. On a microscopic level, it's just this incredible, endless dance of tiny, invisible particles. And once you understand the rules of that dance, you start to understand everything else, like why a hot air balloon rises or why ice floats on water. It's the secret code to the universe. And that leaves us with one final fun question to chew on. We know adding energy, like heat, makes molecules move faster, right? That's how you melt ice into water and boil water into steam. So, what do you think happens if you take a gas and you just keep adding more and more heat? What's the next step? Is there something beyond gas? That's a mystery for another time. Thanks for exploring with me.